We usually just gloss over cables. I mean, you buy the fancy TV, the console, and then you just grab whatever's in a drawer.
Yeah, they're an afterthought.
Exactly. But today we're looking at the PureLink EZH8-030-DT. It's a single HDMI cable that costs, get this, $659.
Oh,
And my first thought was, okay, this has to be some kind of snake oil. How can a cable be worth that?
It's a massive price tag, I get it. But you have to look at the physics here. We aren't talking about, connecting your laptop to a monitor that's 2 feet away.
Right.
This deep dive is about what happens when you hit what some people call the copper cliff.
The copper cliff.
Yeah, when you try to push, say, 8K video across 30 meters, that's almost 100 feet,
Right.
the laws of physics just start working against standard copper wire.
Okay, but playing devil's advocate for a second. I can go online right now and find a 50-foot HDMI cable for, what, 20 bucks?
Sure.
Why shouldn't I just buy that and save myself over $600?
You absolutely could buy it. But for the specs we're talking about, it simply wouldn't work. The PureLink is pushing 48 gigabits per second.
48, okay.
That's the magic number for HDMI 2.1. The cheap copper cable.
Mm-hmm.
It might give you a picture, sure, but it won't give you the full bandwidth. It's just going to choke.
So what are we actually losing? Because 48 gigs sounds like a ton of overhead.
It's all about the color data. This cable supports 4.4.4 chroma subsampling at 8K 60 Hz.
Which means?
It means totally uncompressed color. No corners cut, no blurring on fine text. You're getting raw, pixel-for-pixel information. And it's that density of data that just destroys a signal on a copper cable once you go past like 10 or 15 feet.
So resistance builds up.
The resistance builds up and the signal just degrades. It turns into snow. Or you just get a black screen.
So to cheat that resistance, PureLink basically ditched copper entirely for the data part. This is an active optical cable.
Exactly. It converts the electrical signal into pulses of light. And since light doesn't suffer from electrical resistance, you can run it 30 meters or even 100 meters with zero latency.
And no big power brick needed.
Nope, no external power. It's plug-and-play fiber optics.
Which brings us to installation. Because if you've ever tried to run a cable through a wall, you know the HDMI head is always just a little too big to fit through the hole.
Oh, it's a nightmare.
It's the worst.
PureLink solved that with a detachable connector. But the really brilliant part isn't just that the head comes off to fit through a pipe.
Okay.
You have to remember, terminating a fiber optic cable is incredibly delicate. They engineered a way to detach the whole complex electronic head from that fragile glass core, let you drag it through a wall, and then snap it back on without any signal loss or dust getting in.
That's a huge engineering risk to take.
A huge risk, but they pulled it off.
It basically makes it an installer's dream then. You just pull this thin fiber line through, click the head back on, and you're done.
Pretty much.
But wait, we're talking about glass fiber. Isn't it way too fragile for, a messy construction site?
You'd think so, right? But they list an ultra-small, long-term bending radius of 45 millimeters.
It's flexible.
It's surprisingly flexible. You can actually route it around corners and behind equipment without snapping the core.
Okay, so you've fished this incredibly expensive fiber through the wall, you didn't break it, and you click the head back on. Does it actually work with all the other gear?
Yeah.
Or is it going to cause handshake issues?
That's always the final hurdle. And yet, it supports dynamic HDR, EARC for your high-end audio, but the critical one is that it's HDCP 2.3 compliant.
The copyright thing.
Exactly. The latest copyright handshake. If your cable can't pass that specific check, your shiny new 8K Blu-ray player just won't send the movie. It doesn't matter how good the fiber is. This makes sure the cable is never the weak link.
So let's bring this all back to reality. This is clearly not for the average living room.
Oh, no. This is infrastructure.
Yeah.
It's for, massive home theaters where the projector is on the ceiling 20 feet away from all the source equipment. It's for medical imaging, professional AV control rooms, places where failure is just not an option. Think of it less like a highway and more like a teleportation device.
It's a teleportation device. I like that.
It takes this incredibly heavy electrical signal, turns it into a weightless laser beam so it travels instantly, and then reassembles it perfectly at the other end.
That's a great way to picture it. So looking forward, is this where everything is headed?
It raises a really big question. We are hitting the physical limits of what copper can do.
Right.
As we push for even higher resolutions, higher refresh rates, copper is becoming a bottleneck even at really short distances.
So you're saying eventually we might all be using fiber, even just to connect a monitor on a desk?
It's very possible. I mean, right now, fiber is the expensive solution for the long-run problem. But as our sort of hunger for bandwidth just keeps growing.
It might just become the default solution for everyone.
Exactly. The
Yeah.
price would come down, and fiber optics could replace copper in all our home setups. It could become the new standard.
A future literally built on light. Thanks for listening to this deep dive.